Okay guys, I know you don't want to do this, but we have to take a DCA today. So I want to quickly go over a couple of things. Just a reminder from the quadratic unit, since it's been quite a while since we looked at those and you've been on vacation. So first thing I want to remind you is, remember the quadratic unit, we dealt with imaginary numbers. So if I had a number, let's say 3i plus 6, and let's call that our starting point. That was our current. And let's say our terminal point is at 6i minus 8. The way we find the difference from this is we subtract a from b. So that means we would start with b, so 6i minus 8. And if I subtracted that, oops, I didn't leave room for the subtraction there, did I? 3i plus 6. If we're subtracting, we change the sign of everything in here. So this becomes a positive, that becomes a minus, this sign becomes a negative. And now we add them together. So we have 6i plus a negative 3i, and that gives me 3i. And negative 8 plus a negative 6 gives me a negative 14. So I just wanted to remind you how to do that. The other thing that we also have is, what if we had to multiply anything with an I? So let's say we have a 3i multiplied by 5i. Just as a reminder, we multiply 3 times the 5 and we get 15. I times I gives you I squared. Remember this? And I squared is the same thing as negative 1. So I would substitute in a negative 1 for the I squared, and 15 times a negative 1 is really a negative 15. So just as a reminder, when you have I squared, you always substitute that negative 1. Okay, real quick then, a couple of word problems. If I told you we had a function, and we'll call it h of t, so h is modeling the height of something over time, and this equals, let's use the function negative 16t squared plus 24t plus 7. So this is going to model something that is being affected by gravity. This was the initial velocity, and this is how high it started. So when time was 0, let's say this is a basketball that we're trying to shoot. So we're shooting a basketball at time 0. When I shoot it, it's at 7 seconds. Well, we know this is negative, so the graph is going to look something, going to open downwards like that. Okay. Now if I wanted to find out, let's say, when does that basketball hit the ground? So when is our y value, the height, at 0? There's going to be 2 times that happens, correct? So I would put this into my calculator. So let's go to y equals, and go ahead and put in negative 16x squared plus 24x plus 7. And let's go ahead and graph this. I just want to make my window look like yours so that we see the same thing. So let's go ahead and graph this. Oh, notice when I graph it, it goes up and comes back down. But we can't see the peak, and it's kind of squished together. So let's go to our window. And let's go from x equal to negative 5 for the min. For the max, let's go to x equals positive 5. Our y min, we can leave that. Y max, so remember, went up much higher than our graph. So instead of going to 10, let's go up to, how about 30? And see if we see the whole graph. And press graph. There we go. So it goes up, comes back down, which is what we thought. My picture isn't quite as nice as this. But if we were to go in and take a look at our y-intercept, that's when x is 0, so second table. Oops. Yours probably went right to it because you've reset your calculator. So when x is 0, y is 7, which is what we expected, because that's what the value is right here. But what I really wanted to know was, when it hits the ground, what are the x-intercepts? So to do this, let's go back to y equals, and on y2, let's put in 0, just like we were doing on our cubic function. And I want to see the value, so let's go back to graph. Now to remember how to find the x-intercepts, just like we were doing with the cubic. We're going to go to second, trace, and choose option 5, intersect. So it's telling me this first point of intersection, this one on my thing, is at x equals negative 0.25 and 0. Okay, so when time was at negative 0.25, so we don't really care about negative time, do we? We're really interested in the right-hand intersection point. So go to second trace, option 5, and with your right arrow key, move your cursor closer to that point. And let's press enter 3 times. 1, 2, 3. So this point, the second intersection point, is at 1.75 and 0. So that tells us when the ball hits the ground is at 1.75. And remember, our x value here is representing time. So when the ball hits the ground is at 1.75 seconds after whoever shot the basket. Okay, so that's kind of interesting. Let's say we're interested in, well, back up. Do we care about this one, the negative 0.25? We don't, because it doesn't make sense in this problem because it's a word problem. If I just mathematically was asking what are the x-intercepts, then sure, we care about both of these. One other type of question we might get is, how long is this ball, let's say above a certain height? How high do you want the ball to be above? Let's say, how long is this ball above 12 feet? So I'm going to have to fix my picture here to make this a bit more accurate. So we'll start a new one because my drawing was bad. So ignore over here. And again, I just want to draw this so it looks more like it. So that's what it looked more like in the calculator. So if this was at 7, let's say we want to know how long is it above 12 feet, which is here. So what we're going to do is instead of putting y2 equal to 0, we're putting y2 equal to 12, the height we're interested in. So let's come back to the calculator and go to y equals, and come down to y2. The height we're interested in is 12 feet. So I want to see again how long is this ball above 12 feet. I think that's about how high a basketball hoop is. I don't know, it's very tall to me. Okay, so let's say 12 feet. So again, let's go back to our graph now and take a look at it. There's our quadratic, and it's drawing in the 12 feet line. So again, the things we're going to look for is when does it cross, when does it go above 12 feet, and when does it come below. So to find that intersection, hint, hint, second trace, option 5, and I want to see where those two lines intersect. So using the key, I'm going to press enter 3 times. So it intersects at 0.25 and 12. And let's see when does it come back down below 12 feet. So second trace, option 5. Move the right arrow key to the point we want. We want that intersection and enter 3 times. So at 1.25, comma 12. So at 0.25 seconds it goes higher than 12 feet, and at 1.25 seconds it comes below. If I want to know the total time it was above 12 feet, I would have to look at the difference between these two values. So 1.25 minus 0.25 gives me 1 second it was above the goal or the hoop. Okay, so again, you're looking for the intersection and then subtracting those 2 times. What was anything else we did during quadratics? We had to factor. So let's see, do you remember how we did the factoring, the x factor? I think you guys are pretty good at that. And actually, I don't even think that is on our DCA. So I think you're good. Okay, guys, make sure if you have any questions on how to do the quadratic formula, go ahead and write this down. Actually, I'll have it written up on the board, but our quadratic formula. Remember what? X is equal to negative b, or the opposite value of b, plus or minus the square root of b squared minus 4ac, all of that divided by 2 times a. So just as an example, let's just do one problem. If we had y is equal to 3x squared plus 4x minus 8. If I'm trying to solve that, I just plug it right in. X is equal to negative b, the opposite of the b value. So negative 4 plus or minus the square root of b squared. So b squared is 4, and 4 squared is 16, minus 4 times a, which is 3, times c, which is a negative 8. All of this divided by 2 times a, and my a value is 3. So if I'm working this problem out, which hopefully you're all trying to do or remember, let's see, let's simplify this. So we have x is equal to negative 4 plus or minus the square root 16 minus 4 times 3 is 12, and 12 times a negative 8 gives me a negative, let's see, I don't remember that number off the top of my head. Let's get out of here. So 12 times negative 8 is a negative 96, divided by 2 times 3, which is 6. Okay, so let's simplify a little further. Negative 4 plus or minus the square root. 16 minus a negative 96 means I have to add those together. So 16 plus 96 gives me 112 divided by 6. So just as a refresher of how to plug that into your quadratic formula, and we will write that up on the board for you. Okay? Or actually, we can just pause this video and let's zoom in on the quadratic formula. We can just leave it up there for you. There you go. Okay, so let's go ahead and just leave that up on the board. Okay, good luck, guys. Give it your best shot. We do not want to do a curve on this, so it will count as a daily grade. And again, please give it your best shot. Thanks a lot, and I'll see you on Wednesday.